Okay, we'll get started. Um, Thank you for joining us and taking time out of your day for joining us on this webinar. And our topic is AI in manufacturing and emerging opportunities and new challenges for data acquisition. So with that, we'll look at our agenda. Uh, we'll briefly introduce the speakers that'll be joining me. We'll talk about the business imperatives with the factory goals. And then we'll dive lightly into the technology with all of the terminology that's out in the market today. And then we'll talk about the application of AI specifically in manufacturing and some of the implementation challenges, and specifically around the data engineering that's foundational for good AI practices. And as far as the webinar goes, it is being recorded. The attendees are muted, but feel free to put questions in the chat, and you can see the chat bubble on the bottom of the menu. So I myself am Enrique Herrera. I've got over 20 years experience helping digitize manufacturing operations, and specifically as an Industry 4.0 consultant. But my experience is from large enterprises in manufacturing and information technology and the software and technology communities. And joining me will be Martin Davis, who's got a wealth of experience as a chief information officer and a chief digital officer. And he's currently a managing partner at Denelum, where he coaches CIOs on their transformation strategies and their Industry 4.0 strategies. And then thirdly, Yuri Pilipenko will be joining us as the CEO and the founder of OLSOM, who is a leading low-code, no-code platform and solution for manufacturing and logistics operations. Again, Yuri has over 20 years of experience as well, coming from industrial customers and in the technology solutions vendor space. Now let's get started on the topic. In terms of factory goals, and this is something that we feel that a lot of the factory imperatives really haven't changed over the years in terms of improving throughput or making sure that you're dialed in the throughput accordingly to get the right mix of products at the right time. And then also in terms of efficiencies and making sure that we're keeping our costs down with fast changeovers, specifically on products, reducing waste, and keeping our equipment up and running so that we reduce downtime and take the most efficient maintenance strategies as possible. But also kind of taking into account the optimization of resources, as in the case of energy and water and labor and materials as well, but also taking great care to make sure that the safety of our people is definitely the biggest priority. Now, in terms of a technology landscape, and we do recognize that in the market, a lot of buzz around generative AI, but a lot of these artificial intelligence technologies aren't very new to manufacturing. As in the case of the left side of the Venn diagram, the concepts around robotics have been around for quite a few decades, but also looking at computer vision for inspection and quality and safety, but also with the evolution of natural language, speech, and interfaces. As in the case of our personal lives with our devices, we're starting to see that more in the industrial space as an interface to some of these complex system environments. Now, in terms of the data aspect, we're evolving from the traditional statistical processes and techniques that all of us in manufacturing are well experienced with, to evolving into data science, using more sophisticated technologies and more advanced algorithms and solution techniques, including machine learning in terms of using that to accelerate the training of models and to be able to kind of complete data sets sooner, increasing the time to value. So as far as kind of where we see the application of these AI technologies, the existing ones and the emerging ones, we'll start off with the data analysis piece. Recognizing that the manufacturing environment is a complex environment of a variety of different siloed systems with a lot of different types of data. And with the increased computing, higher frequency data, and having all of these data silos are very difficult for folks in manufacturing to keep an eye on all of these data coming at them. So clearly using AI technologies to help look at all of these data that are occurring in these silos or bringing them together, but also trying to identify new efficiency opportunities and new interactions in these different data sources and these physical phenomena. In terms of optimization, as I mentioned, the energy efficiency one is becoming more and more paramount with companies' sustainability goals, and understanding the interaction between those energy resources and those operations can be achieved with some of these more advanced analytical and AI technologies. Also, we've seen the application of artificial intelligence in terms of quality, in terms of not just the computer vision for inspection, but being able to look at the data from some of the processes and the interactions with the quality. Again, that winds up being complex because the folks working in the operational piece and the folks working in the inspection piece may be not physically close to each other, and they may not be in sync time-wise. But Martin, I guess some of these other areas that you've got experience with?
Yeah, let's talk about a couple of them. So supply chain management, for instance. If you think about the volatility of customer demand that we're having these days, people want everything now, but they also want to change their minds as well. So that leads to a lot of impact on manufacturers, a lot of impact on supply chain. And you think about how COVID, for example, disrupted supply chains. All of these things lead to a very volatile situation where the supply, I don't know, think of it as a planning and scheduling puzzle to start with. How can you optimize that to get what you need, get it when you need it, but not too early, not too late, especially given the potential for disruption. And then you could take it to the next level, is how do we get to a dynamic supply chain change? And I think that's an area where artificial intelligence and in the future probably quantum computing as well, the combination of those two, looking at how you optimize everything, how you actually rearrange things in a dynamic way to best deliver on your promise to your customer, best deliver your manufacturing. So that's one kind of area. Another one's predictive maintenance. We're all familiar with the original time-based maintenance where you'd say, okay, once every 6 months we'll change this bearing. Whether it's done 10 hours or 5,000 hours, we'll change this bearing, which leads to lost time where you're taking the machine out of service. It leads to wastage. That bearing might be good for another 5,000 hours, yet you've just changed it. So that's cost. All of that is unnecessary cost. We then moved more to condition-based maintenance. We're looking at data from what is going on. How do you see, okay, that bearing is got more vibration now. Therefore, we need to do something about it. Therefore, we'll change it. So that's more the condition-based maintenance. But now where we're going is more predictive and prescriptive. So AI has the capability to recognize patterns in thousands of pieces of data, things that a human eye are not going to notice, or a very experienced human eye might notice after a lot of time, but AI can do easily. So, for example, you may have a lot of data about how a machine is performing, and AI can over time recognize the symptoms that start to appear very, very early, tiny little indications that say this machine is going to fail. So by looking at that and recognizing those patterns starting to reoccur, the AI can predict when maintenance is going to be needed. And then taking that to the next level is prescriptive, which is that not only can the AI identify when something is likely to fail, but it can also then schedule the downtime, schedule the maintenance, order the spare parts, have everything ready to go. So just need the maintenance team to come in and actually make the change. So that gets from we were at time-based all the way through to predictive maintenance and then into prescriptive maintenance. So if we move on to talk about the kind of future of manufacturing and how AI can help that. So we'll just talk about 3 of the items on this page just quickly. So the first one's about mobility and stock movement. And how do you optimize that? So a lot of people are familiar with automated guided vehicles, AGVs. And those are now morphing into AMRs, automated mobile robots, which is instead of an automated vehicle that will go down a track or go down a set path, it's now into a robotic movement tool that can think for itself. It's told where to go and pick something up and where to deliver it. And it works out how to get there. It knows its way around. It can find its way around. If one of the aisles is blocked by a forklift, it can route around it. It's not just going to sit there and wait dumbly until somebody moves the obstruction out of the way. So we're seeing more of that. And if you think of that in terms of you've got a large warehouse or a large factory, you've got stock that's moving, maybe it's raw materials coming from the warehouse going to a production line. You may have finished goods coming off the production line onto a pallet that then needs to be moved into the finished goods warehouse. All of that can happen using AMRs. So that's one area, and the AI is thinking for itself. It's understanding what's needed. It's optimizing its route, etc. Also within that whole sphere of movement and stock is optimizing movements around a factory. So how can AI help you optimize where people are moving things, not just robots? So paths of movement, how to improve your factory layout, how to improve your warehouse layout, and optimizing stock locations, for example. How do you do all of those things? So AI can help with the sorting that and understanding how to make things as optimal as possible. Moving on to the second one, safety, collision, and accident avoidance. So there's a number of aspects here where AI can really help. First one is protective equipment, personal protective equipment, PPE is often referred to. AI and vision systems using AI can monitor whether somebody has the correct PPE for use of a machine. So that's a very big safety thing. So an AI vision system can detect, are you wearing safety glasses? Are you wearing a hard hat? Are you wearing a reflective jacket? Those types of things can be identified. And the machine can refuse to allow the person to operate it unless they've got all the PPE on. And then there's the other area, which is more analytics based, which is analyzing the data of movements around an industrial complex, be it inside a factory, inside a warehouse, inside a yard, and identifying key danger zones, understanding where the near misses have occurred. You're going to know where actual accidents happened because you've usually got a safety log of something that's been written up, etc. But what you don't know is where all the near misses have occurred. And using some of these tracking and capability within AI, you can understand we have some danger zones and we can do something about that, be it proper signage, be it a walkway, whatever else, to avoid accidents in that area. And then the last one I wanted to talk about was visibility of manufacturing operations. So this is what we all know and love. It's how do we understand what's going on? What's happening from line speed to production volume, to downtime, to OEE, all of that type of stuff. And that's all about data. And we'll come to talk about it as well. So there's various other things on here. The types of stuff you will normally see, like cost savings and environmental stuff, labor costs, operational challenges, and ensuring efficiency and reducing waste. Those things, we've touched on a little bit, some of those, but those are some of the other areas. So moving on to the next slide. But once you have decided you're going to implement some more of these advanced tools, what does it take to actually make it happen? How do you get to that situation? So first of all is buy-in. How do you get buy-in for this project? And this has always been a difficult one, especially for factory managers and things like that. Most plants are very strictly controlled on cost and things like that. And I've often found in my experience, it needs someone at the C level in the C-suite, like a VP of engineering or a VP of operations, that is going to help get this to the CEO and get funding for a large type project that might move things forward. Because most plants individually don't have the budget for doing this type of stuff. So it's about getting that funding, getting people involved early on, getting people sold on the massive difference this can make. Yeah, like some of the other things we talk about with Industry 4.0, use of technology can make a massive difference to how a plant will work, how a plant will be more efficient. And we've got a lot of opportunities out there. The majority of plants I go into, there's very few that are taking advantage of all the opportunities they can. And whilst there's always some upfront investment required, the payback on these things is usually pretty huge. If you think about the amount of wastage in a lot of plants, be it labor, energy, whatever else, all of that is money. And how you move forward is, extremely important. And the last piece that we'll talk a bit more about in a second, the biggest implementation challenge if you're trying to do AI in any plant is data. You need good data. So moving on to Yuri.
All right, thank you, Martin. So why data is so crucial for AI? Basically, it's not a secret that any AI model, any AI algorithm is using the data to train, to learn. And we are using the data for education of the AI and for continuous improvement of its knowledge and its capabilities. Therefore, it's a foundation. The data is foundation for our decision-making network. And the quality of the data has the direct impact on all of our decision-making. Enrique, can you move to the next slide?
Yeah.
So, this slide is explain a little bit the challenges related to the data collection. So, what our customers often see as a major, first of all, it's a collection of data itself. Many of the manufacturers, still these days do not collect data or collect fragmented. Another challenge is once you started to get data, there's the question is the quality of the collected data sufficient enough? Imagine you have some old meter measuring, for example, pressure from the machine, and there can be a lot of noise, a lot of anomalies in collected data that needs to be filtered out, and the data have to be normalized before it becomes valuable to train your AI model. And last but not least, we are talking about the fragmented IT environments in the factories, where different data is hosted and owned by different systems. And sometimes it's really challenging to get all of this data meaningfully together, normalize it and contextualize it so that it can be used collectively in training of your AI model. Let's move to the next slide, Enrique. This slide demonstrates the importance of data engineering process. Andrei Karpathy, who used to be a PhD known in the AI world, he stated that when he was working as a PhD, he spent most of his time working with models and algorithms. But once he switched, he changed to Tesla and put his hands on some practical job. It appeared that sorting out data would take 75%, around 75% of their training cycle with their AI models. So in general statistics show that data scientists spend as much as 80% of their time basically cleaning up and preparing their data. So knowing all that challenges, we work closely with the customers to get the data well organized and sorted. So at OLSOM, we developed the real-time low-code, no-code platform, which is the core of our product suite. And this software allows our customer to collect data from different sources, like applications, equipment, workers, and whatever other sources that you can imagine on the plant floor. Then the data can be, cleaned up, normalized, aggregated, contextualized, and visualized. So further, this clean data and contextualized data would be used for training your models. We have quite good experience, quite broad experience at OLSOM with our customers to train models in preventive maintenance and prescriptive maintenance area for numerous of different equipment. Especially, we have some very good results with injection molding presses. So,
well, I think, Yuri, that's a really important point in terms of the whole data side of things. And I've seen it myself, other companies I've worked with, you spend so much of your time trying to get that data corralled. Because if you think about from a manufacturing line, if you've got data coming from a tag on, in a PLC coming through, you're going to get data that comes through. You may get some high values out of range. You may get some low values that are totally out the bottom. You may get gaps in the data and everything else.
right.
When you're trying to train a model on data that's unclean like that, it causes bizarre results at times. So you're looking at how you normalize that data, how you actually get a clean set of data that machine learning and AI can actually rely on. So you're filtering it out, you're adding in, you're kind of doing an average, get rid of gaps or whatever it might be. So there's all of these types of things. And I think, as you were telling me earlier, there's so many things that you have to do. And it's, everybody says AI, let's do AI. But 70-80% of the time you're spending, let's sort out the data, because the data is such a beast.
Yeah, absolutely. I agree with you, and that's what we also realize. But even with the I would say even with the low quality data, you can find the patterns that bring this disruption in the data quality. So, and you can configure your process of data collection and aggregation in a way that you could put different, like filters, for example, like you can cut off, like anomalies and normalize your process. So yeah, there are many things that you can do to prepare your data to give it, like much better quality and fit it, to your model to train. So I completely agree with you.
Let's take these minutes here, these 5 minutes here, to take a look at some of the questions in the chat. Martin, it looks like there's one for you. You mentioned kind of getting buy-in, and from your experience, how would you, or how have you kind of gotten buy-in from unionized factories that we're all familiar with?
Well, I think that there's a couple of sides to this. So whenever you're getting buy-in, let's talk generically to start with. Whenever you're getting buy-in, you start with how do you approach it? So you approach it by saying, what is the value we're going to generate from this? How does it make a difference to the business? And that may be a monetary value, maybe improvement in things like safety or other things like that. So start there. That's the kind of very important piece, to make sure you understand why you're trying to do this. In a unionized facility, and in any facility, to be honest, it's not just unionized, but think about the basic principles of change management. And the basic principles of change management is get everybody, as many people you can, involved early. Help them to feel a part of what's going on. It's, yeah, the biggest issues you get with implementing a new change is when it's a surprise. It's, oh, look, I've got this new thing, it's wonderful. Here you go. Yeah, that's caused the biggest problems. It causes so much resistance. It causes shock. It causes anxiety, all these types of things. So involve the unions as early as possible. Get them on board and help, let them feel that this is a benefit to the workers as well. Because keep in mind, you may be implementing AI and it may take away very unwanted tasks that they don't want to do anyway, and free people up to do tasks which they are finding more rewarding, they're finding better anyway. Yeah, we have a big problem around the world with finding factory workers a lot of the time. So being able to focus the workers you do have on more skilled positions that are usually more valuable to the end deliverable is good. So I would get people involved early. I would make sure that you are explaining what the thoughts are, use their input as you can to help mold what you're doing, and just get everybody involved as much as you can. I know it's not always easy, but yeah, it happens over a large amount of time.
Yeah, I guess there's another question in there related to this topic in terms of AI capabilities displacing human jobs. And I guess my perspective is there, obviously we leverage human intelligence first, and then we start kind of augmenting the human intelligence with some of the artificial intelligence. So yes, as you mentioned, Martin, right, kind of getting rid of some of those mundane tasks so that they're doing higher value tasks and that they're complementing the worker instead of displacing the worker. Totally agree. I guess, Yuri, there's one in here probably for you in terms of natural language interfaces on solutions on the factory floor. What's your take on that?
Oh, well, there's a wide area of application of natural language. Obviously, with the big ongoing issues to fill in the open positions, it's often not easy to find the people with the proper work experience on the market. And that's where actually AI can help with natural language interfaces to the people. So we can imagine, for example, when you need to have, for example, consultant or configurator or human who would do some job requiring some specific knowledge of, for example, declarative languages or scripts or things like that. That's where AI and in particular the generative AI could be of a great help to increase, or improve the workers' experience, guiding them with the natural language instead of requiring some special knowledge. Does it make sense to you, Enrique?
Yeah, absolutely. Absolutely. That does make a lot of sense. In terms of, there's a question about ROI, and I know, Martin, you talked about the business benefit, and Yuri, you're talking about kind of people. What's your perspective in terms of ROI and, how to, set expectations on the returns here? Any thoughts there, guys?
I think the place I would start with saying is, okay, like anything, and AI is the latest thing, but there's plenty of other stuff out there as well. I would start by saying, all right, what are you changing? What are you changing? What difference is it going to make? Are you eliminating certain pieces of work? Are you speeding up processes? Are you improving quality? Are you improving safety? All of those things have a value. And so I would start there. I would say, right, first of all, be clear on what you're actually trying to do. implementing any technology for technology's sake is a bad idea. Let's start there. So starting with the premise of, I want to implement AI. Yeah, give me some money to implement AI. Okay, well, what does that mean? Yeah, if I'm a CEO, I don't know what that means. Yeah, okay, I might have read about it in an airline magazine or something, but what exactly are you trying to do? It's a bit like saying, I need another machine for my factory. Okay, but why do you need that machine? What's it going to do? How are we going to get benefit from it as a company? AI is no different. Yeah, implementing better data collection off your production line is the same thing. What am I going to get from it? How am I going to change what I'm doing? And then convert that to a value. So, for example, if you're saving some mundane tasks, for example, I don't know, stacking cardboard boxes or something. Yeah, okay, well, that has a value associated. So that's how you calculate your ROI. Your ROI is going to be obviously the cost of implementing and the amount of money you're saving over a period of time, and does it balance? So I would always start with, what are you trying to do? And then what impact does it have? What does it change? Yuri?
Yuri, your thoughts?
Yeah, that echoes our recent conversation about the objectives, right? That actually, yeah, we set the objectives. Like if we are going to acquire computer vision, machine vision, the question here, what objective we are trying to pursue, right? So if the objective to replace like workers with the computer vision, and the ROI is obvious. The question is related to the accuracy, right? Like what should be the accuracy, the expected accuracy, and does the existing data and existing models would they allow to secure this level of accuracy, right?
Right.
But yeah, as Martin, I completely agree with you in terms that you know what you need to achieve, right? What's your objective? And based on that, you can quantify the ROI.
And the same is true for anything you're trying to do with technology, and anything else, to be honest, is, people say, okay, I want this shiny new thing, I want to buy it. Okay, but what are you actually trying to do? What's your requirements, effectively? What do you need?
But in terms of kind of closing out, because we're kind of at time here, I encourage you. First, I wanted to thank you, Martin and Yuri, for taking the time and for your insights, for sure, and encouraging the audience to, in talking to OLSOM, of the approach of the data engineering to get some of these kind of started on this journey of AI. Thank you very much for your time.
Thanks, everybody.
Thank you.
Thank you.